All right. So we're back to Haskell. I don't remember where we ended off. I remember that we checked the is prefix and is suffix, right? That's fine. We check if an element is in a list. Partition takes a list and returns a pair of lists. Oh. First list is the result contains the element that satisfies the predicate, and the second contains all the ones that don't. Right. We can just split the list into... Oh yeah, all of them, so we iterate through the entire list, indeed. Right, span and break are done once they encounter the first element and doesn't satisfy the partition goes through the entire list always. Yeah, so span and break can be called... Yeah, it's at the element, so you can call that on an infinite list, while partition, not a good idea to pull that on a... on an infinite list. That wouldn't work. Find takes a list and a predicate and returns the first element that satisfies the predicate. Wait, we just return bigger than 4. Right, the first element, just a single element though, yeah. Notice the type of find, yeah, it's a maybe. Oh, I remember that, we were looking for maybe. Maybes were good. Maybe, remember when we were searching for our first stock? I remember reading this, yeah. Element index, alright, we get the index of our element. It returns a number. It's on our third spot. Wait, fourth, because we start lists at 0. Element index, wait, returns a list of... Wait. Is that how you spell indexes? No, that's something different. In case of the element we're looking for crops up in our list several times. No, it actually looks through all of the times our... Yeah. Every time our predicate is found. Yeah. Where are the spaces? Exactly, yeah. Every time it finds a space, got a space on that location, on this location, and on this location. Straightforward. Find index. It's like find, but it maybe returns the index of the list, the first elements that satisfies the predicate. Wait. Oh, right. Instead of returning the actual value, it returns the index. Makes sense. We already covered zip and zip with. We noted that they zip together two lists either in a tuple or with a binary function, meaning such a function that takes 2 parameters. But what if we wanted to zip together 3 lists or 4? No, or zip 3 lists with a function that takes 3 parameters. For that we have zip3, zip4, etc. and zip with 3 and zip with 4, etc. These variants go up to 7. While this may look like a hack, it works out pretty fine because there aren't many times when you want to zip 8 lists together. There's also a very clever way for zipping infinite number of lists, but we're not advanced enough to cover that just yet. Alright, just leave that behind, yeah. Zip with 3. Alright, just... That's how we zip them. Just like with normal zipping, lists that are longer than the shortest list that are being zipped are cut down to size. Chop it down. Lines is a useful function when dealing with files or input from somewhere. It takes a string and returns every line of that string in a separate list. Yeah. The new line is the character for a Unix new line. Backslashes have a special meaning in Haskell strings and characters. Exactly. New line, new line. Exactly. Unlines is the inverse function of lines, and it takes a list of strings and joins them together using... Right. Wait. Oh, right. Oh, of course, right? If you want to split them up and have specific items for each line, or if you just want one thing with the whole text, like if you want to do, yeah, whatever you want to do. Words and unwords are for splitting lines of text into words or joining a list of words into text. Very useful. Alright, so it does the same thing. It just does it with space instead of new line. Right. Alright. We've already mentioned nub. It takes a list and weeds out all the duplicate elements, returning a list whose every element is a unique snowflake. The function does have a kind of a strange name. It turns out that nub means small lump or essential part of something. Well, in modern days it means something else, doesn't it? In my opinion, well, actually, small lump, that might work. In my opinion, they should use real words for function names instead of old people words. Do you mean archaic words? Oh. Alright, nub. Cut them all out. Lots of words and stuff. Lots of stuff. Oh, right. Space is a character. Unique one at that. Delete takes an element and a list and deletes the first occurrence of that element in the list. Right. There's probably a delete all. We can probably do that easily enough ourselves. Ooh, it's the list difference function. \\. It acts like a set difference, basically. For every element in the right-hand list, it removes a matching element in the left-hand one. Every element on the right hand, it removes a matching element on the left one. Alright, so we remove 2, 5, and 9 from this list. And it removes the first matching element, not all of them. Yeah, exactly. Exactly, we only remove the first B that we encounter, the first I and the first G, not the other B's. No, sorry, wait. Yeah, exactly. This is BIG. I was thinking, does it remove big necessarily? No. It doesn't remove a string. It removes the characters. Yeah, doing this one is like doing delete 2, delete 5, and delete 9 to this list. Right, I gotta remember that. The function composition. That is something, isn't it? Union also acts like a function on sets. It returns the unions of two lists. It pretty much goes over every element in the second list and appends it to the first one, if it isn't already in yet. Oh wow, watch out though. Watch out though. Duplicates are removed from the second list. Okay, so it joins them in. Duplicates are removed. So we don't add another... Wait. Right. Unions, but we only add unique stuff, I guess. Yeah. Intersect works like set intersection. It returns only the elements that are found in both lists. Okay. Inert takes an element and a list of elements and can be that can be sorted and inserts it into the last position where it's still less than or equal to the next element. In other words, insert will start at the beginning of the list and keep going until it finds an element that's equal to or greater than the element that we're inserting, and we'll just insert it just before that element. All right, so insert if we want to keep, that's for creating a new list, but keeping the order. 4 is inserted right after 3 and before the 5. In the first example and between 3 and 4 in the second example. If we use insert to insert into a sorted list, the resulting list will be kept sorted. Exactly. What length, take, drop, split at, double exclamation mark, and replicate have in common is that they take an int as one of their parameters or return an int. Even though they could be more generic and usable if they just took any type that's part of the integral or num type classes, depending on the functions. Yeah, I suppose that is the case. They do that for historical reasons, however, fixing that would probably break a lot of existing code. That's why data.list has their more generic equivalents named generic length, generic take, generic drop, generic split at, generic index. All right. Right, if you don't want to turn the int into something else, you can just import this data.list module and do it with these instead for the historical reasons. Yeah. For instance, length has a type signature of length, take a list and then return an int. If we try to get the average of a list of numbers by doing like this, let xs, right, check for if 1 through 6 is in the sum of the list. Oh man, it's just confusing. We get a type error because we can't do a division on an int. Yeah, exactly. I remember when we first read about this, that it takes an int. I was thinking, isn't that a good thing that we are being restrictive? But it's really not, right? It's because of the type inference, right? It might increase the compile time a tiny bit. But I mean, how often do we compile programs? Right? When it is compiled, it doesn't matter anymore. So it would be better for the programmer to have the generic ones. Yep. Because we could do this if we wanted to. Because at compile time, that's the only time it matters, right? Or if it's only efficiency of compile time that gets affected, really. Right. On the other hand, the type sign of generic length right. Generic length, on the other hand, has a type signature of num a and then a list of b into a. Exactly. Instead of an int. We just need a num, which is way easier because a num can act like a floating point number. Getting the average by doing the thing works out just fine indeed. We would have to add a function in here where we would have to turn these like from int, I think is the call. Yeah. No, maybe that creates a string. Right, we would have to call a function to make them generalized, generic. Then they would be inferred into a num a. Oh, actually, I think from int would work. Because if I recall correctly, from int just takes an int and tries to generalize it as much as possible. It tries to give it this, right? So we could get a string from an int depending on our context. But in this situation, it would become a float, just because we're using division because of type inference. Type inference is kind of cool, the way Haskell does it, yeah. Right, the nub, delete, union, intersect, and group functions all have their more general counterparts by nub by, delete by, union by, intersect by, and group by. The difference between them is that the first set of functions used we check for equality, whereas the by ones also takes an equality function and then compare them using that equality function. Group is the same as group by. Oh, right. So we have just how we test. Yeah, what we test. Yeah, it takes an equality function, so we can check greater than, less than, whatever. We can make all of these work a little bit differently if we want to, yeah. For instance, say we have a list that describes the value of a function for every second. We want to segment it into sublists based on when the value was below 0 and when it went above. If we just did a normal group, it would just group the equal adjacent values together. But what if we want is to group them by whether they are negative or not? That's where group by comes in. The equality function supplied by functions should take two elements of the same type and return true if it considers them equal by its standards. Right, so we have some values here, and we group by, and then we take like this long function where we create a function where we check for, that's a lambda function with an x and a y. If x is smaller than 0, then y is greater than 0. Wait. It returns... This returns true. And we check for equality if y is lower than... Wait. I'm confused. What is the y and what is the x? From this here, we clearly see which sections are positive and which are negative. The equality functions applied takes two elements and then returns true only if they're both negative or they're both positive. Exactly. What are the two elements? This equality function can also be written as... Here we go. That's a mess. Although I think the first way is more readable. An even clearer way to write equality functions for the by function is if you import the on function from data function. On is defined like this. Okay. Why do we take two elements? By functions should take two elements of the same type. Right, let's check this out, right? We group all of these together, and then we group all of these. Oh, right, that's what we're doing. We're grouping them. We don't change the order when we group. So down here, this is where we split, right? We get a false. So all of these, but down here we get another true, so this is another ordering place. Okay, that makes sense. That's why we test xy, because we test x, we test y. Then we test x and y, and x and y. I'm assuming that's how it works. All right. On, it's defined like this. Right, we take a function that takes some value, and returns some other type of value. And then we have another function that, wait, that function returns a function that makes A into B. Oh shit, this is confusing. And then A to C. Oh man. All right, function on another function. Yeah, that is what we're doing. We're calling a function on another function. And we create a lambda function, x, that we call on y. And that function, wait. We call, all right, g. Now by calling f, we call g on both our things that's going on. Oh man, this is some difficult shit, yeah. I don't completely get this. Right. The on is kind of right. We take a function on another function. So doing checking for equality on less than 0 returns an equality function that looks like this. Okay. I don't remember how the lambdas worked. Right, x. Right. It returns an equality function. Right. X is greater than 0. Yeah, that's what we're doing. And we're checking, yeah, equality on that. On is used a lot with the by functions because with it we can do, oh, still don't quite get it. Right. We can do group by. Right, and then we check for equality on everything that is... Oh, right. We check equality on the true value. That's what we're doing, yeah. We replace this, right? We get a true or false value on this. And then we check the equality on the next value. And we group it, right? So, first thing returns true because it's less than 0. The second one returns true because it's less than 0. And that is what we group by. We group by true. True, true, false. Boom. And now false, 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 false. And we group them. Oh, boom, true. Now we group by true again. True, true. And then boom, false, false. Exactly. That's what we're doing. So we're checking for equality on the output on this thing. We're calling a function on a function, but it's like we call it on the result of the function. Well, that's not it. It like in functional programming, the function doesn't really have a result in that way. Because yeah, this is writing this is equivalent to writing, well, true or false, depending on what value we have, right? If we just show you what I mean. Oh, actually, let's do this instead. Right. Oh shit, we can make it a little bit bigger even. There we go. Writing, let's see, -1, 0, and writing, those are the same. They are equivalent. So it says false here, or it says true here. And we can check for equal or true or false. And since we're grouping by, we group them by Boolean values. And is that always what we do? Grouping on Boolean values? Yeah, because we have two different groups. Either on this side of the group or that side of the group, right? This group or that group. Very binary, I guess. Right, very readable indeed. Yeah, it becomes readable down here and understandable. You can read it out loud. Group this by equality on whatever the elements are greater than 0. Yeah. Similarly, the sort, insert, maximum and minimum also have their more general equivalents. Functions like group by takes a function that determines when two elements are equal. Sort by, insert by, maximum by, and minimum by take a function that determine if one element is greater, smaller, or equal to the other one. Right. The type signature of sort by is sort by. Right. Yeah, we check those and we return a function that has an ordering, and we do that on two lists. If you remember from before, ordering type can have a value of LT, EQ, GT. Lesser than, equal to, greater than. Exactly. The sort is the equivalent of sort by compare, because compare just takes two elements whose type is in the order type class and returns their ordering relationship. And since we can use that with on, so we can use the same way we used this before, I guess. Lists can be compared, but when they are compared lexicographically. So we compare characters to other characters. What if we have a list of lists and we want to sort it not based on the inner list's contents, but on their lengths? Well, as you've probably guessed, we'll use the sort by function. Exactly, yeah, because if we sort a list of lists, we just compare the first element of each list, right? Right, like if we do sort, and we do a list where we have beta, alpha... Shit, I don't know this. Caesar? Is that the one? I don't remember. Wait. Oh, we can't even call that. Doesn't work on a list of lists? No, we can't call sort. Wait. What did sort do again? Not in... Oh, we don't even have sort. Have not imported sort. We don't even have that. It's part of the module that is not imported yet. I don't remember which module it's part of. Ah. It was data something. Data list? Yeah. Right, no wonder it doesn't work. Wait, was it... I'm pretty sure it was a data list, yeah. Oh, thanks of glass of ethanol import data.list. That did work in here, right? They did something that we did like, what, like this? Plus... something like that, but we probably just can import data.list. Yeah, and then we can do the sort thing that I wanted to do. Yeah, exactly. And they sort on the first character. Exactly. Hello, Colgate on tap. Nice to see you again. Alright. He's asking for some inspiration. So the inspiration is continue tingling. Very inspirational. Yeah. Gotta remember that. Remember to tingling. Continue to tingle, yeah. Alright. So what we do then is sort by. And the way to do it is sort by. I think that's part of it as well. It takes... What did it take? We do it like this. Alright, compare. Shit, I don't remember what compare did. Compare on length. Sure, we do just what they did. Did we import on? I'm not so sure. We did not. Where did on come from? Data.function. Import data.function. Syntax error. No, I did something. Ah. I didn't do ticks. Wait, which one is that? Is that the one? Is that the tick? No? Shit. Where's my tick? That's the one. There we go. And now we get them in the length of... Yeah. Right, compare. Oh, right, we take compare on length. Actually, what did compare do? Oh yeah, it just returns an ordering, exactly. On needs to have backticks, right, yeah. Screwed that up. I forgot about that. That is, the backticks is to make it an infix function. Yeah. Otherwise we would have to do... Wait, like this? Would this be the equivalent way of doing it? Yeah. On compare length. But it's easier to do it like an infix, yeah, with the backticks. I just didn't remember where they were on my keyboards. I don't, like... This is the first time I've used backticks since, like, a few weeks ago when I used it on Haskell last. But never use it otherwise, yeah. Alright. Thanks, glass. Wait, glass of ethanol, yeah. That doesn't sound very healthy, does it? Yep, you could do blah and then ticks fmap blah instead of doing blah and dollars. Yeah, exactly. Prefix infix. I remember that because it bothered me when we first learned about infix and suffix, how to change those. It also bothered me to take a typical infix like this. If you wanted to change that to a prefix, you had to do it this way. It bothered me because it looked different. But it's fine, yeah. Right, awesome. Compare on length. Man, that reads almost like real English, doesn't it? Yeah. Glass of ethanol says, yeah, my username is a play on my real name. Oh, nice. Oh man, I can't figure that out. Your real name? Glass of ethanol. I can't even guess. Yeah. I can't imagine someone drinking that. A glass of ethanol. Shit, I always forget which is which. That's the shit that kills you, right? Or is it just booze? No, booze is just alcohol. Ethanol is the one we use for gasoline. Oh, ethan, of course. Glass of ethan. Ethanol is in alcohol. There we go, yeah. Colgate in on tap says, I would have guessed ethanol. Pretty close. Pretty close, yeah. Alright. if you're not sure, if you are not sure how exactly the on works here, compare on length is the equivalent of, right, a lambda function. We take x and y, and we take the lex of x, and we compare it to the length of y. Yes, exactly. Right, so that's I think that's what has confused me a little bit today, that I've forgotten, is that the sort functions, since we do have it now. Alright, that doesn't really help, right? But they sort, they compare indexes to each other, right? They compare this to that, and then this to that, and then this to that. Right. And then in that comparison, they decide if to sort or not, right? If they decide to sort in one group or the other group. Yeah. Right. When you're dealing with by functions that take an equality function, you usually do equality on something. And when you're dealing with by functions that take an ordering function, you usually do compare on something. Alright, check for equality or compare on something. Colgate on tap says that ethanol is one kind of alcohol. Most of the stuff that ends in alcohol? Like, for example, sorbitol, xylitol, and propanol, and methanol. Lots of stuff. It's good for you, some of it, yeah. Right. That feels like a valuable thing to remember. Or have access to. Is that part of the cheat sheet? Do we have that? Right, if we search for sort in our cheat sheet. What about on? Damn it. On. Great name to search for, right? Yeah. What else was the other one? We got... Oh, this probably does not take any modules though, does it? Actually, we can search for module. Module. That was not what we were looking for. As constraints. Export. Here we go, module. It feels like it's just simplified how to import modules, yeah. Probably doesn't give any information about the actual modules. That makes sense, I guess. Right. Data.character. Alright. The data.char. Char? How would you pronounce that? Char. Which is weird because it's character. So car. Char. There we go. Char. Becomes weird. The data.char module does what its name suggests. It exports functions that deal with characters. It is also helpful when filtering and mapping over strings because they're just lists of characters. Data.char exports a bunch of predicates over characters. That is, functions that take a character and tell us whether some assumption about it is true or false. Here's what they are. Is control a control character? I don't know what a control character is. Is a space? I know what a space is, though. Yeah, if it's lower, upper, alpha. Letter. Alphanumerical. Letter or a number. Okay. Is printable. Control characters are not printable. What's this? Oh yeah, just an alarm. This digit is octodigit, hexdigit, letter. Wait. So it's equivalent to is alpha, is letter. Is mark, Unicode mark characters that combine with the preceding letters to form letters with accents. Use this if you are French. Nice. I think Denmark does that as well, right? They combine A and E like that. They make it into one character, I think. Is number, is punctuation, is symbol, is separator, is ASCII, is Latin 1. First 256 characters of Unicode. Okay. ASCII upper, ASCII lower, sure. All these predicates have the type signature of character into a bool. Yep. You check a character and returns a Boolean value. Most of the time, you'll use this to filter out strings or something like that. For instance, let's say that we're making a program that takes a username and the username can only be comprised of alphanumeric characters. We can use the data.list function all in combination with the data.character predicates to determine if the username is all right. Right, all is alphanum. Nice. False because we got spaces. Cool. In case you don't remember, all takes a predicate and a list and returns true only if that predicate holds for every element in the list. Yeah, all is alphanum. Looking great. We can also use a space to simulate data.lists function words. Alright, words. And we can do it ourselves by group by. Check for equality on isSpace, because isSpace returns true or false, and we check for equality and... Yeah, exactly. When we group by, that's why we usually use the check for equality, and we have Boolean value, because that we have our false sorting, and we got our true sorting, exactly. I like that. Just like the other, when we did compare. Yeah, that's when we... not when we wanted to sort. What did we want to do? We just looked at it. Right? Damn it. What did we do? No, we did sort, but we did compare. Right, if we wanted 3 different values. Wait. Oh well. Let's move on. Well. It kinda does what words does, but we're left with elements of only spaces. What shall we do? I know, let's filter that sucker. Yeah. Filter, not any is space, group by, wow. Wasn't that very intricate way of filtering out spaces? There must be a better way to do that. But I suppose since we are using the is space, that's how you do it with is space, I guess. The data.char also exports a data type that's kind of like ordering. The ordering type can have a value of lesser than, equal, or greater than. It is sort of enumeration. It describes a few possible results that can arise from comparing 2 elements. The general category is also an enumeration. Are you kidding? Is that the data type that data.char exports? General category? That's super helpful. What category? The general one. Yeah. For what? I don't know. It's just for stuff. No, we categorize generally. Yeah. It presents us with a few possible categories that a character can fall into. The main function for getting the general category of a character is general category. Wait. It has a type of general category. Okay. It takes a character and it returns a general category. There are about 31 categories, so we won't list them all here, but let's play around with the function. Oh, Right, we have these categories that these functions check for, right? Kind of want a tree here, right? Because general category, is it only uppercase letters, or is it a member of other general categories as well? Map, general category, all of these. Space, control, uppercase. Or is the function, right? We have... great song, by the way. Right, we had is alpha, right? That checks for both lower and uppercase letters. So alpha maybe takes... Wait, where are we? Oh, it just takes all of the uppercase letters and the lowercase letters, probably. That's what the function does. Rather than having I'm comparing it to the type classes, right? It's not quite what's going on. But they are similar, I guess. Since the general category type is part of the EQ type class, we can also test for stuff like general category C equals to space. Right, 2 upper converts a character of 2 uppercase, spaces, numbers, and the like remain unchanged. Oh, it doesn't throw an error, it just... Yeah, that would have been a super annoying if that threw an error, right? Because if you want to call that on an entire super long string, you would want only to make all the characters to upper. And the same thing to title converts... Yeah, title case. For most characters, title case is the same as uppercase. Wait, is it? Oh, I thought to title would just capitalize the first character in each word. Digit to int converts a character to an int. To succeed, the character must be in the ranges 0 to 9, A to F, or A to F. Yeah. There we go. Into digit does the same thing. 15 is F. The ORD and the CHR functions convert characters to their corresponding values and vice versa. Wait. ORD A character. Oh, alright. So it's similar, right? But it just works. Wait, int to digit. Isn't that the same thing as... Alright. Did we... I don't think I imported this thing, did I? Import data.char. Alright, import data.character. Right, we're importing all the things, aren't we? Alright. Right, if we take char 97, turns A. Wait, into digit. Digit to int. Alright, there we go. No. Int to... Oh! I wasn't paying attention. Yeah. It just turns it to a character. Yeah. That won't work. Yeah, this won't work. That one just... Not a digit. Just need a digit. I was confused. How did I miss that? I was just confused by the F because I was thinking that was a character, but it's not, right? It's a number. It's hexadecimal? No. Octagonal? Sorry, I don't know maths. Numbers. Yeah. Right. The difference between ORed values of two characters is equal to how far apart they are in the Unicode table. Yeah, exactly. This is the Unicode table. That made sense to me. The Caesar cipher is a primitive method of encoding messages by shifting each character in them by a fixed number of positions in the alphabet. Okay, we can easily create a sort of Caesar cipher, wow, of our own. Only we won't constrict ourselves by the alphabet. Nice. Bulletino says it is character. Int to digit returns a character. Yeah. A character that is equivalent to a number, right? It doesn't... These are number characters. Numerical characters. These are Unicode characters. So yeah. Numbered character, right? We would get is number. The character is numeric. That's what I meant. All right. Time are we at? Still got a few more minutes left. We can look a little bit on this Caesar cipher, I guess. Wait, what day is it today? Yeah, Thursday. Right. Code int and string to string. Right. We map it. That's why we have a string that we're gonna map. Yep. And we shift it. Let ords be map ord message. In map character shifted. Shifted is where we shift? Oh, right, that's the number. How far to shift it. Right, so we take... Here, 97 was A, right? But we can take +3. We shift it by 3. Wait, sorry. There we go. So if we take that, and from this we can make ciphers more and more complicated. And sooner or later you'll get a cipher that is so complicated that you need a computer to crack it. And there we have it. The reason for the invention of the computer. Yeah. I saw that movie about Alan Turing, right? Second World War and all that. All right. I'm just gonna take this call real quick. Jag kommer ner, ska bara avsluta här så kommer ner om 3 minuter till. Ja. Yes. All right, that was my meeting. So, yeah, we continue with the ciphers and whatever tomorrow. Yeah, thanks for hanging out and yeah, have a good one. See you next time. Cheers.